Swayam Prabha. Digital India. Educated India.
Now, let us work out this example. It is given in this Bishop's book. Okay. This is your matrix, and we will work out another more interesting example after this. This is A. Okay. So, what is the first step? What do I want to do? First step would be to find what is A minus lambda E, right? What is A minus lambda E? Minus 1 minus lambda, then 0 minus 4, then 0, 2 minus lambda, 0, then 2 0, 5 minus lambda. This is your A minus lambda E matrix. Very easy. What can I do when I have this matrix? I can get the data of this and put it equal to 0, and what will I get then? No, what is that equation called? Characteristic equation of matrix A. You see what I was talking about? We have not even talked about X yet. We have not even tried to say what is X. All I have done is, I have written a matrix A, and from there I can write this characteristic equation of the matrix A. What will the characteristic equation be? Can you work it out? Expand the determinant and tell me what it is. So, this is the equation, lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. And the way she did it is that she did not even write the entire equation, isn't it? She just took the factors, that is why it was much faster. So, that is a smart way of doing it. And the answer she gave is also correct. There is an amazing matrix where lambdas are 1, 2 and 3. Just work it out and satisfy yourselves. So, we will just believe, say, has everybody got 1, 2 and 3, or do we have some other value? 1, 2 and 3, alright. Now see, we know the matrix A and we have determined the 3 eigenvalues. Do we expect to get 3 eigenvalues, or do we expect to get more or less? Why? N. No, forget about lambda, it is an n by n, 3 by 3 matrix, right, n equal to 3. Okay. Now, what we can do is, for each of these eigenvalues, I can find the eigenvector. How will I do it? Just write that equation, right? This equation, A minus lambda E x1 equal to 0. What is the meaning of x1? 1 is the number corresponding to the number of eigenvalue. Okay, I, the second number, alright. So, what is the, now we can put 1 here. For lambda 1 equal to 1, you just put 1 here, what do you get? What is the matrix? Minus 2 0 minus 4, 0 1 0 and 2 0 4, right. And now see, is it a little clearer now? Huh? Now see, I am writing x11, x21, x31. Achal? Got it now? So, we are working it out for the first eigenvalue. So, we are working with the first eigenvector. Of course, nobody has said that this has to be the first eigenvector. You could have taken it to be the second or third, it does not matter. Okay. That is in your hands. But the point is, there will be 3 eigenvectors and there will be 3 eigenvalues. So, now once you have this, the rest is simple. How many equations will you get? 3. How many unknowns do you have? 4 unknowns, 3 unknowns. So, we should be able to work it out. Let us see. What is the first equation? Minus 2x11 minus 4x31 is 0, right? What is the second equation? x21 equal to 0. What is the third equation? 2x11 plus 4x31 equal to 0. So now you have 3 equations, 3 unknowns. Can you solve and get the values? I will give you the first value, the most difficult one. Oops, no, I will give you that first value later. But I have given away the answer. You cannot. Why can you not use these equations to get the 3 values? There is redundancy, right? There is redundancy. Is it necessary that we will have redundancy no matter which matrix we use? So now what is the way out? Where will the last equation come from? Yes. Of course, I have played spoil sport here by giving away the answer by mistake. I forgot the sequence of my animation. But the point is that whenever you use eigenvectors, you always want them to be normalized, right? Otherwise, you have a lot of redundancy. You just multiply by 3, multiply by 4. That does not make any sense. So they are always normalized like this: x11 square plus x21 square plus x31 square is equal to 1. Normalizing means setting the value to some particular value, setting it to some particular value. Okay. So you have encountered this condition of normalization in many places, right? Where? Yeah. Orbitals. Fine. So now can you work out the values? I will give you the most difficult one. x21 equal to 0. Now just work out the easier ones. 1 by root 2, 1 by root 5, minus 2 by root 5 and 1 by root 5. Alright. So these are the 3 x values. What is the eigenvector then? What is the first eigenvector? Minus 2 by root 5, 0, 1 by root 5, normalized. Fine. Now I want you to work out lambda 2 equal to 2 or lambda 2 equal to 3. Maybe let us split. Lambda 2 equal to 2, this row, lambda 2 equal to 3, lambda 2 equal to 2, lambda 2 equal to 3. Let us work it out. Okay, for lambda 2 equal to 2, what is the matrix? What is the A minus lambda 2 E matrix? Minus 3, 0, minus 4, 0, 0, 0, 2, 0, 3. Now work it out. What are the equations? Minus 3x12 minus 4x32 equal to 0. Second equation is fantastic. 0 equal to 0, it better be. Then third, what is the third one? 2x12 plus 3x32 equal to 0. Fourth, x12 square plus x22 square plus x32 square equal to 1. Work it out. What are the what is the answer that you get? 0, 0, 1, 0 is the answer. What about lambda 3 equal to 3? What is the matrix? Minus 4, 0, minus 4, then 0, minus 1, 0, 2, 0, 2. So what is the first equation? Okay, minus 4 x 1 3, then minus 4 x 3 3 equal to 0. Second one, minus x 2 3 equal to 0. So notations are all problematic. Then third, you get a redundant equation. Fourth one is the normalization condition. And what is x13 then? x13? There is no minus. Acha, x33 is minus 1 by root 2. x13 is 1 by root 2. x23 is 0. Yeah, yeah. Not a problem. not a problem. This is how they have written, that is all. Achha. So, now see, what we have been able to do is, using a given 3 by 3 matrix, we have been able to work out the eigenvalues as well as the eigenvectors, right. Now, the question is, does it work only for this matrix or for certain matrices, or should it work for any matrix, any square matrix? Should it work for any matrix, any square matrix, or should it work for only some matrices? Let us take a brute force approach and then we will figure out. So, we have about 23 people present today. So, what I want you to do is write down a matrix, a 2 by 2 matrix each, and this 2 by 2 matrix cannot be null matrix, cannot be diagonal matrix, cannot have the same elements, and for your convenience keep the numbers less than 10. You can use minus, there is no problem. So, maybe 2, 8, minus 1 and 5, something like that. So, just write down the matrices, any matrix that you want, we will find out now. Done? Chose your matrix. This is like one of these magic tricks that we used to do, right? Name a number, then add 5, multiply by 3 and so on and so forth. Finally, I will tell you what the answer is. Have you written the matrix? Right? 2 by 2 is fine. Do not write 1 by 1, that will be problematic. 2 by 2 matrix. Now, for this 2 by 2 matrix, can you work out the characteristic equation? Do it. It is very simple. Characteristic equation will be of which order? Second order. Do it. Write down the characteristic equation, solve it and get the roots, and tell me if you encounter any problem. Write down the characteristic equation. How will I solve it? Second order equation. What is that formula that everybody learnt in class 11 or maybe earlier for quadratic equation? Minus b plus minus root over b square minus 4ac divided by 2a. So, that is all we need for this. What will happen if b square is less than 4ac? That is possible. Then we will get a complex number, that is all, but that does not mean that it is not an eigenvalue. Work it out. Got it? What are your roots? I mean, what are the roots of the equation? 5 and minus 1. Lucky chap, he has not got an imaginary number. Tell me if you get an imaginary number. You got an imaginary number? Somebody? Good. That is also good. I think it is enough if you just work out the roots. If you get the roots, are you convinced then that the rest will work out? You get the roots means you get the eigenvalues, right? So, if you have an eigenvalue, then you better have some eigenvector. It is just that it might be complicated. What are the roots that you got? I am sorry? Root 7i and 2 minus root 7i. So, if you have eigenvalues like that, life will be a little complicated, that is all, but then you are going to have corresponding eigenvector, is not it? So, this exercise tells you that you can actually, so what we are talking about is not just something in the air abstract mathematics, you can actually put numbers to this. You take any square matrix, you can find out the eigenvalues and the eigenvectors, And like many things that we do, we find the values first and vectors later. The way we formulated the problem is that we have the matrix, we have the vector, and then we find the eigenvalue, but we all love back calculation, right? Okay, can we move on?